In this video, I'm going to show you how to factor when you have four terms. This is called factoring by grouping. I'm going to show you how to factor by grouping using the area model. Your first step is to always look for greatest common factor. On this example, I do not have a greatest common factor. So my next step is always going to be to draw a box. We have four terms. So I'm going to take each one of those four terms and put it in one of those four boxes. So I'm going to put my first term in the first box, my second term in the second box, my third term in the third box, and my fourth term in the last box. From here, I am going to factor, I'm going to look for the greatest common factor in each row and in each column. The greatest common factor of my top row, let's see, that's going to be 3x squared. The greatest common factor in the bottom row is going to be 2. The greatest common factor of my left column is 8x. And the greatest common factor of my right column is -7. Remember, the wonderful thing about factoring is that you can always check your work. 3x squared times 8x is 24x cubed. 3x squared times -7 is -21x squared. 2 times 8x is 16x. And 2 times -7 is -14. So right now, my factors are 3x squared plus 2 and 8x minus 7. You always want to make sure that you have factored completely. Here, I have something being squared, and I only have two terms. So the only way that I could factor this more is if I had a difference of two squares. Well, this isn't a difference because I'm adding. And 3 is on a perfect square, neither is 2. So this one is factored completely. If I look at this term is linear. Remember, linear means your highest exponent for your variable is 1. Here with x, my exponent is 1. So this is linear, so that means that I'm done factoring that one as well. So when there is nothing left to factor, this is your answer. Let's try that again with this example down here. Your first step of factoring is to always look for a greatest common factor. Here I do have a GCF of 6. So I'm going to go ahead and factor that out to begin with. So that's going to leave me with 4n cubed plus 7n squared minus, let's see, 96 divided by 6 is 16n, and then 168 divided by 6 is 28. Now I want to factor completely. So now I want to factor inside the parentheses. To do that, I'm going to use my area model. I'm going to take each one of those four terms and I am going to write them inside of each one of the boxes of the area model. The greatest common factor of my top row is n squared. The greatest common factor of my bottom row is -4. The greatest common factor of the left column is 4n. And the greatest common factor of my right column is 7. Let's double check our work. N squared times 4n is 4n cubed. N squared times 7 is 7n squared. -4 times 4n is -16n. And -4 times 7 is -28. So right now, my factors are 6 from my greatest common factor times n squared minus 4 times 4n plus 7. Now we always want to factor completely. This first number 6, this first factor, I can't simplify that any further because it's just a number. Let's look at the second factor. Well, here it's not linear, it's quadratic. I know that because the highest exponent of the variable is 2. And so because this is a quadratic with 2 terms, this means that I could, I might be able to factor using a difference of 2 squares. Here, let me grab a different color. Something is being squared minus something that's being squared. Well, n squared is n squared and 2 squared is 4. So I could factor this using a difference of 2 squares, so that's going to give me n plus 2 times n minus 2. If I look at this next factor of 4n plus 7, this is a linear factor, so I know that one's already factored completely, so I can just go ahead and bring that one down. So this is my final answer.